Hello, this is Scholar Strife. I'm doing some math. Today we're looking at Algebra 1, looking at different types of numbers. So, let's start off with real numbers. Real numbers are the numbers we usually use. 1, 2, 3, 3, 4, 5, stuff like that. Whole numbers, starting with 0. So whole numbers are just no decimals, no halves, no fractions, or anything like that. Just 1, 2, 3, 4, and so on, starting with 0. And they're all positive. Integers are all whole numbers with negatives. So, -3, let's have a triple dot going backwards, -2, -1, 0, 1, 2, 3, ... So those are integers. Rational numbers are numbers that, so we have a fraction where a and b are integers, so they can be positive or negative. They just cannot be 0, or b cannot be 0. So can it be written as a fraction? So 1/2, 3/4, 7, which is 7/1. Irrational number is a number that can't be written as a fraction. So you might have heard of the number pi, or we can call this the square root of 12. Punch that into a calculator, you'll just keep getting a long list of numbers that you can't write down. And let's talk about absolute value. So the absolute value of the number a and 0 on the number line. So it's the distance between a and 0 on a number line. So let's look at what it looks like. So here's an example. So if you ever see a bar, these bar-like things around a number, that means the absolute value of 5, which means the distance between 0 and 5 on a number line is 5. Absolute value of -5. So if I looked at a number line here and say here's 0, here's -5, how far is it from 0 to -5? It is still 5. Distance is always positive. We can't have negative distance when we're measuring things. So that's how absolute value works. And we'll do more examples in a bit. So let's ask some questions here. Does an integer have to be a whole number? Yes, it does. Or does an integer have to be a whole number? Oh, no, it doesn't. So no. For example, if we use -2. So remember, whole number are positive numbers. So 0, 1, 2, 3, 4, 5. Integers can be negative or positive whole numbers. So -2 is an integer, but not a whole number. Part B, does a rational number have to be an integer? No. So we have the rational number 1/2. It's rational, but not an integer. 1/2 is rational, but not an integer. Does an irrational number have to be real? Yes. The real numbers is all the rational and irrational numbers. So the real numbers include all rational and irrational. So it includes both. So here's the real number system. It includes all of these. Okay. So, example 2, how can we tell if a number is rational or irrational? So if it's on the rational side, we have all the fractions, all the integers, all decimal numbers that stop. And what I mean by stop is 1.25. Not 1.25678 ... Yeah, so all decimals that stop, and all repeating decimals. And I'll give you an example about that. So let's say we have 0.33333 repeating. That's the same thing as 1/3. 1/3 is a fraction, so that is a rational number. So irrational numbers, any square roots that is not a perfect square, and what I mean by that is if we have the square root of 4, that is considered a perfect square because the square root of 4 is 2. Something that's not a perfect square, like square root of 7, square root of 8, 10, 12. And then this would be any decimal number that goes on forever. Oops. But does not repeat. So if you look up pi online, you'll notice that it doesn't repeat, but it keeps going on forever and ever. Okay, next. So we're going to look at a number, and we're going to check all the boxes that apply. So negative 23, is that a whole number? So remember, whole numbers are just positive ones. So no. Is it an integer? Yes. Is it rational? Yes. Is it real? Yes. It's either rational or irrational. It can't be both. Okay, let's move on. Next example. 3.5. So 3.5 is not a whole number. So we're going to write this up here. Whole integer rational, irrational, real. So 3.5 is a real number. Now, is it rational or irrational? So remember, rational, we include decimals that stop. So it stops at 0.5. So yes. Is it a whole number? No. Is it an integer? No. Is it rational? No. So example, 4 divided by 0. So we have a rule that, and if you punch this in your calculator, you'll get undefined or error. We cannot divide by 0. Can you split 4 people into 0 groups? You cannot. So this is nothing. This is not a whole number. This is not an integer. This is not rational, irrational, or a real number. Okay, example, square root of 11. Is it a whole number? No. Is it an integer? No. Is it rational? No, because it's not a perfect square. It is irrational. Because you punch in your calculator, you'll get a bunch of decimal points that don't repeat. And then, is it a real number? Yes. So I'm going to go down this list and make sure, check to see if all these are real numbers. Square root of 25, that's real. Pi is real. 8 is real. And 0 is real. Okay, so let's go back to this again. So part A, square root of 25. The square root of 25, one number times itself is 25, and that is 5. So is that a whole number? Yeah. Originally it wasn't, but you have to simplify it. Integer, yep. Rational, yep. Irrational, no. Pi is not a whole integer, or it's not a whole number, not an integer, not rational. It's irrational, and it's real. 8 is a whole number. That's positive, yep. Integer. Positive whole numbers work too. Rational, not irrational. 0, boom, boom, boom. It's a whole number. It's an integer. It's rational. Okay, place the following numbers in order on the number line. So I'm going to notice that all these are bigger than 0, so I'm going to put 0 over here. And let's say 0.2 is over here. 0.2, 0.3, 0.4, 0.6, 0.8, 1. So the lowest one is 0.175. So 0.175. Sorry for the handwriting, but make sure you're listening as well. 0.175 is just a little bit close to 0.2, but not exactly there. And then we have 0.25. So 0.25 would be in between 0.3 and 0.2. And then we have 0.4. And then we have 1. So we just make dots. Same thing. So I'm going to have this be 0. And I'll do 0.2, 0.4, 0.6, 0.8, 1. Or 1.0. So we have a number at 0. And then we have 0.2. And then 0.34. So it's around here. And then 0.75. So here's 0.7. And we're going to go in between 0.7 and 0.8. So 0.75. And then lastly, 0.8. All right, let's solve these absolute value problems. So remember this notation here is absolute value. And once again, the distance away from 0, starting at -5, is 5. The distance from 4 to 0 is 4. So think of this as parentheses. If you're doing any PEMDAS problems, do the inside first. So -1 plus 2 is 1. So 1 minus 3 plus 4, absolute value. 1 minus 3 is -2, and then we have plus 4. So the absolute value of 2 is 2. The distance away from 0. Alright, so if we have a fraction, it'll still be that fraction. Just the distance away from 0. So part B, absolute value of 0 is 0. C, the distance between -1 and 0 is 1. So your answer is always positive. It can never be negative because we measure distance positive. And that's that for section 1.3. Make sure you're doing your homework. Have a good day.